Hello everyone, this is part F of name reaction series, and in this video we are going to cover name reactions starting with alphabet F. In this video we will cover following name reactions, that is Finkelstein reaction, Fittig reaction, Friedel-Crafts Acylation, Friedel-Crafts Alkylation and Fry's rearrangement. Now first of all, covering Finkelstein reaction, it is a very simple halide exchange method in which halogen atom of alkyl halide is exchanged with the iodide of sodium iodide. In this reaction, alkyl iodides are prepared by the reaction of alkyl chlorides or alkyl bromides with sodium iodide in the presence of dry acetone. The side product NaCl or NaBr formed in this reaction is precipitated in dry acetone, which facilitates forward reaction according to Le Chatelier's principle. Now taking up example of Finkelstein reaction, in the first example we are going to react bromomethane with sodium iodide in the presence of dry acetone. In this reaction there will be exchange of halide ions, that is Br- and I-. After exchange of halide ions there will be formation of the main product, that is iodomethane, and the side product sodium bromide will be formed. Common name of iodomethane is methyl iodide. Now taking up second example, we are going to react chloroethane with sodium iodide in the presence of dry acetone. In this case also there will be exchange of halide ions, that is Cl- ion with I- ion. After exchange of halide ion there will be formation of the product, that is iodomethane and sodium chloride. Iodomethane is commonly known as ethyl iodide. Our second reaction is Fittig reaction. In this reaction, haloarine or aryl halide is treated with sodium in the presence of dry ether. In this case, 2 moles of haloarines are required. It is a very simple reaction in which there will be removal of NaX, that is sodium halide, 2 moles, and there will be formation of simple diphenyl product. Now taking example of chlorobenzene, we are going to take 2 moles of this and going to react this with 2 moles of sodium in the presence of dry ether. After removal of 2 moles of NaX, diphenyl will be formed. Our third reaction is Friedel-Crafts Acylation. It is a reaction in which aromatic compound like benzene or its derivative is treated with acyl halide, that is carboxylic acid halide, to give acyl substituted product. It is an electrophilic substitution reaction which takes place in the presence of anhydrous aluminium halide, which is the Lewis acid, and it works like halogen carrier in this reaction. In this reaction, hydrogen part from benzene and halide part from acyl halide combine together, giving out HX. The leftover part, that is RCO, which is acyl group attached to the benzene ring, forming acyl substituted benzene as the main product. Since in this reaction there is substitution of hydrogen atom of the benzene ring by acyl group of acyl halide, that is why the reaction is known as Friedel-Crafts Acylation. Now taking up example of Friedel-Crafts Acylation reaction, we are going to react benzene with ethanoyl chloride, which is commonly known as acetyl chloride, in the presence of anhydrous AlCl3. In this reaction, H part from benzene will combine with Cl part of ethanoyl chloride, forming HCl. Now, CH3CO part of ethanoyl chloride will combine with the benzene ring, forming acetyl benzene, which is commonly known as acetophenone. Our fourth reaction is Friedel-Crafts Alkylation reaction. It is a reaction in which aromatic compound like benzene or its derivative is treated with alkyl halide in the presence of anhydrous aluminium halide. Just like Friedel-Crafts acylation reaction, there will be removal of HX part and the main product will be formed by the substitution of hydrogen part of benzene ring by alkyl part of haloalkane. The product form will be alkyl benzene. Since in this reaction there is substitution of hydrogen atom by an alkyl group, that is why the reaction is known as Friedel-Crafts Alkylation. Now taking up example of Friedel-Crafts Alkylation reaction, we are going to react benzene with chloromethane, which is commonly known as methyl chloride, in the presence of anhydrous AlCl3. In this reaction, the hydrogen of benzene will be substituted by methyl group, that is CH3. It is electrophilic substitution reaction. In this case, CH3 positive will substitute H positive from benzene ring. The removed H positive part will combine with Cl minus part of chloromethane, forming HCl. The main product will be toluene, which is commonly known as methyl benzene. Now our fifth reaction is Fries rearrangement reaction. When esters of phenols are treated with anhydrous aluminium chloride, then the phenolic ketones are obtained. The reaction involves then migration of acyl group from phenolic oxygen to the ortho and para position of the aromatic ring, forming the main products. In this case, ortho and para substituted products are formed. As given in the example, the first one is structure of phenol, in which on the benzene ring OH group is attached. If hydrogen of the phenol is substituted by RCO, that is acyl group, then it is known as phenolic ester. Wherever the group is attached, the position just next to that are ortho positions, then it is meta position, and at last just in front of the group there is para position. So in this case, rearrangement takes place at ortho and para position, as the group attached is ortho-para directing in nature. Now taking up example of Fries rearrangement reaction, we are going to react phenol with ethanoic anhydride, which is commonly known as acetic anhydride. In this reaction, hydrogen part of phenol will be removed with CH3CO part of ethanoic anhydride in the form of CH3COOH, which is acetic acid or ethanoic acid. The leftover part CH3CO will combine to the phenoxide ion, forming phenolic ester, that is phenyl ethanoate. This phenyl ethanoate in the presence of anhydrous AlCl3 undergoes rearrangement reaction, forming orthohydroxyacetophenone and para-hydroxyacetophenone as products. Thank you for watching this video. Please like the video, share it and subscribe to my channel. Thank you.